Announced with Chapella upgrade, Ethereum community is expecting a proposal to remove self-destruct from the Ethereum mainnet. If you are a smart contract developer or generally curious to know what's going in with the Duncon upgrade, stay with us. Welcome to PEEPanEIP episode 115. I am Pooja Ranjan. In this Duncon special episode, we are going to be talking about EIP-6780 self-destruct only in same transaction. Documented in March 2023, the proposal is co-authored by Guillaume Ballet, Vitalik Buterin, and Dan Craig Feast. It is currently in the draft status. To learn about the EIP, what changes will it bring to the Ethereum mainnet, we are joined by one of the co-authors and Go Ethereum developer, Guillaume Ballet. Welcome to the show, Guillaume.
Well, thanks for having me.
We have had Guillaume on the show earlier to share information on EIP-3102 binary tree structure, a proposal to change the storage structure from hexadecimal to binary. If you're interested to learn more about the proposal, check out the link available in description. The general format of this show includes a presentation followed by question answer. But before we dive deep, for our new viewers and listeners, may I ask Guillaume to share a brief introduction and the journey in the Ethereum ecosystem?
Sure. Yeah. So I'm Guillaume. I'm working on the Go Ethereum team, and I'm also heading another team inside the EF that's called Stateless Consensus, where we work on bringing about stateless Ethereum. So yeah, that's currently focusing on Verkle trees. How did I get into Ethereum? I mean, I was interested in cryptocurrencies since 2014, and I had an opportunity to join the guest team in 2017, so I did that. And since then, I got dragged into protocol and protocol development and also research. Yeah, so most of my time is spent working on Verkle trees, and we have just put up a website to explain Verkle trees and how they impact Ethereum, how you can help, how they work, and so on. So it's that website, verkle.info. And yes, another thing I can say about myself is a lot of people ask me about my avatar, so that's why I put like this big picture on the slide. And the origin is that it comes from there's some kind of stairway in Zug, right next to the lake, where somehow at the end of this stairway, for some reason, it just gives you a view of the lake underwater. It's pretty muddy, so you don't really see anything. But when you take a picture, it looks very like this is a room full of hazardous materials. So I like it because I see my role in Ethereum precisely to do this, to look at all the hazardous ideas in research and try to bring them into Go Ethereum.
Yeah, absolutely. Well, thank you so much for the introduction, and I'm sure it will help someone to consider joining the adventurous ecosystem. So yeah, we can proceed with the presentation. Let's peep in.
Yeah, so I'm going to indeed talk about 6780, which is really a pretty simple, I mean, at least the description is pretty simple. It's about neutering self-destruct while not breaking as many contracts as a complete removal would be caused by a complete removal. So the principle is that if self-destruct is called in the same transaction that created the contract, it's retaining the old behavior. But if it's called in a further transaction, then it could, like, the instruction has the behavior of another instruction we propose, which is called send all, where all the funds are sent to the target address, but the nonce, the code, and the storage are kept as is. Okay, so let's maybe talk a bit about self-destruct. Why do we want to remove it? Well, let's look at why we wanted to have it in the first place. So initially it was called suicide in the initial proposal, and I think that was actually the much better name because it really implies what you're doing when you're trying to call this instruction. It's an instruction that is fraught with peril, and yeah, it was initially meant to, as the first mitigation effort to prevent state growth, try to reward people from cleaning up after cleaning up after themselves, trying to delete contracts they no longer need to recover some gas. But you can see from the number of account creations since the beginning of Ethereum that it has really does work to, it has really, the initial intent was not realized. So, and on top of that, this instruction has many perils. So I will just go over some of them. The first one is that it's not really deterministic. I mean, maybe non-deterministic is a bit exaggerated because, of course, the deletion is that can be understood. But the problem is that the gas cost is the same regardless of the amount of deleted data. So if you look at the yellow paper, which I have just put an excerpt of in the top right corner, you can see whether you delete a big account, like an account with a lot of storage, as is represented by the tree in the bottom, like the very large tree in the bottom left corner, or a very simple account with only 2 slots in the bottom right corner, you will delete, that will cost you exactly the same amount of gas. And that is a problem because, potentially if you delete a very large contract with gigabytes and gigabytes of storage, you should not pay the same amount of gas as a very simple contract. And if you try, the worse still, if you try to actually account for the amount of data that is accessed and all the disk access and all the computation that is done, you could actually run out of gas while deleting a contract. So then you will end up in a state that is undefined, and that's really not good. So yeah, that's I would say that's the first problem with self-destruct. Next problem was brought out to light with the story of the Parity Multisig. So what they did is they had this wallet management code that was relying on the central library. So when you would deploy a wallet, and they deployed a multitude of them, they would all rely on the same contract that they call the library. And for some reasons I will not get into, someone got ownership of the contract and self-destructed it. So all those wallets that needed this other contract, this central contract, to do all their logic could no longer function. And that means those wallets were effectively, like all the funds in those wallets were effectively locked. And that includes Parity, that has lost a lot of funds in this hiccup. Another problem is that it allows for, like, with the existence of the instruction create2, it allows for code mutability. And this is a problem, for example, if we're going to move into account abstraction. So here you have, like, this is a small an attempt at representing account abstraction. You have a lot of users with their transactions, and they don't want to pay the gas cost of realizing all those transactions on chain directly. So they go through a relayer that does some kind of aggregate, packages all the transaction, and creates a package transaction to be applied to the wallet on chain. The problem is, if a hack such as the Parity one happened, the wallet gets self-destructed and all those transactions end up being completely irrelevant. Worse still, those users could actually, like someone who self-destructed the wallet could replace it with another wallet that is either extortionary or just has a backdoor or whatever. Those users then be able to use their transactions, but the package transaction, like this wallet, could do whatever it wants with the package transaction. So this is a problem. And the last problem, for me the biggest, it's the way we propose to do Verkle trees. So we, instead of having one tree that contains all the accounts and then each account has one subtree for all its storage slots, everything would be spread over one single tree. And there's no way we lose the ability, given an account, to enumerate all its slots, all its storage slots. Or conversely, given a slot, there's no easy way to find which account it belongs to. So this is extremely easy, of course, as you execute the block. But when you look at the tree as a whole without knowing the pre-images of every key in that tree, you cannot really see what slot belongs to what account. So effectively, the only way we could do to delete an account, the only way we could self-destruct an account in Verkle tree would be to just delete this account. But right, sorry, I should have explained. The red square represents an account, and all the green squares represent the slots belonging to this account. It's a simplified model. The Verkle tree structure is a bit more complicated, but that's just to get an idea. So we would delete this account, and the rest of the slots will remain in the tree, because we can't tell which, once again, which slot belongs to which account. And as the consequence to this would be that if someone uses create2 to recreate this account, they would inherit all the slots that were there before. And this is a problem either because it could be a malicious contract, such as like same thing as I explained for the account abstraction problem before. It could be the same thing. You create a contract and access all the, for some reason you delete a contract, an ERC32, an exploiter could find a way to delete the contract and replace it with a new ERC20 contract that they control. So they would access all the tokens. They would control all the tokens of the network, really. And the other problem could also be, I mean, if it's not necessarily malicious, it could also be some technique where, because it happens, there are some contracts that like to create some subcontract and then self-destruct them. This could happen, but then because the state was not properly deleted, all the previously initialized state will be there, and that might disturb the proper execution of the contract. So it's a very fickle and difficult and dangerous instruction. I just want to go over the client support. So most clients have implemented it. There's a caveat here for RETH. So I contacted every client to confirm except RETH. I didn't have the time to do it. So I went to their source code. I see it's not there. So I apologize if they have implemented it and I missed it. But yeah, otherwise everybody except Aragon confirmed that they had an implementation. It hasn't really been tested yet. I mean, it's been tested. Each client did their own test, but it hasn't been tested on the testnet yet, because since it's packaged with 4844 and the 4844 is the major EIP to go into Denkun, yeah, it gets the priority, but of course it will be tested before we get into the fork. Simply, it's not the priority right now. Right, so I was asked to talk a bit about the security. So we commissioned a company called DDoB to do the audit. I just stole one of their slides. And basically what this says is that the impact of using EIP-6780 is very mild. So they looked at different use cases and they tried to understand why people use self-destruct, and especially why do they use self-destruct in conjunction with create2. So this is, they established that the impact of like removing self-destruct period would be problematic. But with this approach of only allowing the deletion to occur in the same transaction that's created it, we would cover most of the use cases of this pattern of create2 and self-destruct, and we would still get all the benefits of removing self-destruct. Because one thing I should have specified is, for example, with the whole Verkle tree method, if the contract gets deleted before the end of the block it was created in, it never hits the tree. So it will never be stored in the tree, so we don't have all those problems. Of course, it's not perfect. We had a few comments. This is the only one that was actually polite. Unfortunately, it's not really clear who this person is or what project they work on. So I'm also making a call. If you have a use case that makes that would point out that our analysis was incomplete, we would like to know that if it's really a problem. In this case, just reading this description, which is of course not complete, it seems to me that the best way forward would be for this person to tell all its users to migrate their tokens before the fork. Maybe there's a good reason not to do this. So yeah, it's starting to get pretty late to provide this information. So please do it ASAP. Because I just wanted to mention there were some other EIPs we looked at, other method we looked at. So the first one was the complete removal. It's clear that this is a bit too harsh to perform. So that's why we came up with 6780. There was another one, progressive. So it's basically the same idea as the difficulty bomb. Every time someone uses self-destruct, the self-destruct becomes more and more expensive. And the idea is that it would force people to realize that something is wrong and come up with a migration path themselves. So that would be a user-activated migration path. And there was another EIP which was deactivate. So that would just, when you call self-destruct, instead of just deleting all the data, it would just mark the contract as deactivated. This one suffers from the problem I described earlier, that you could, in a Verkle tree context, you would reactivate the contract and still obtain the former state. So something could be poorly initialized, or the contract could find itself in a state it would not expect itself to find itself. And there's another one that's called Verkle compatible. And this one was deemed too complex compared to the benefits it would bring. So we are aware of some contracts that would be broken. So far as we can tell, it doesn't justify the complexity that this approach would be. And it's, how does it work? A very quick summary. It's like when you want to access a slot, you hash the address of the account and the number of its slot. We would add a self-destruction counter to this hash. So every time you want to access a slot, you have to mix in the deletion counter. And so the result would be that the new, like a contract that is reactivated would find itself with a blank, with an empty state. So this is something that is possible. It's especially easy to do with Verkle, at least on paper, but it's still a bit more complex than what we would be. It's a bit too complex to implement, given the amount of broken contracts we see who are not very worth saving, for lack of a better word. So we could potentially enable it later, especially after Verkle tree, if it makes sense. If we do find contracts that are worth saving, or worth the complexity at least. So yeah, like I said, make yourself known if you have a use case, because from what we can tell, there is nothing really worth the complexity, but if there is, we want to know. Yeah, and that's pretty much it. So I'm going to share the slides. So you can go check the EIP, the EELS implementation. So EELS is the executable spec written in Python. So yeah, there's been an implementation recently, the report by D. Dobbs. And yeah, one thing I want to press as a conclusion is that even if self-destruct is somehow retained in some capacity, do not use it. It's an instruction that is fraught with peril. And we would like to, I mean, there's no promise we will not get rid of it in the future. We might re-enable it in some form in the future if it makes sense, but our preference would be to remove it altogether. So yeah, don't taunt the devil, just don't use it, basically.
All right. Yeah, it was a wonderful talk. I really appreciate you explaining the self-destruct and why was that added to the Ethereum in the first place and the progress made so far. Sharing high level of Verkle tree info was also good. And for our listeners, we have recorded an episode on Verkle tree with Tancred Feast a while ago. Please check link available in description. Thank you so much for this, because I see that you have covered most of the questions that we have listed here. Though I would like to pick up a little bit more to just get into the in-depth of some of the small nits and bits that we perhaps missed. As you mentioned in the slide that there were multiple EIPs for self-destruct, and you also explained very well that 6190, which is Verkle compatible, seems to be a bit complex. I'll be curious to hear, what are the major advantages that we see this proposal making changes on Ethereum, and why we prefer this over any other for Dencon upgrade.
Yeah, so the reason why we prefer this one is because it seems like the best compromise, I would say. It doesn't break too many contracts, at least as far as we're aware. And it's simple enough. It doesn't hit so when you create a contract, at the end, all the contracts, all the new addresses are kept in some location in memory. And then at the end of the block, they get flushed to disk, unless they get destructed in the meantime, of course. So For us, it's nice because it's contained. Everything is done in memory. There's no going back and forth between the disks. Like, we get rid of those use cases. So it's really much simpler. And it offers all the nice features that we want. I talked about Verkle trees, but also if we look at replacement with a biomalicious contract, like what I mentioned for account abstraction, that doesn't really become a use case because presumably users will not try to use the account abstraction contract or the relayer at the very moment the wallet is created in the very same block. So for the Parity Multisig, that would be the same case, right? If you delete the library contract, well, you end up with a wallet whose funds are locked, but presumably you did not fund your wallet in the very same block that your, or at least in the very same transaction that your wallet was created. So yeah, we have this kind of use cases. So it offers good security, it offers the simplicity, and it doesn't break too many contracts. So that's why we picked that.
And I think those are very good reasons to have this proposal being selected, along with the flexibility of enabling self-destruct back if somewhere developers feel like it is important to have it back. Talking about that, I have noticed that most of the questions on Fellowship of Ethereum Magician, which is a discussion to link to this proposal, have been answered. And I saw one question, which perhaps maybe in a day or two, you guys will answer it over there. It's by a user 0xstraw, and that is about the consensus for using create to or self-destruct pattern in future going forward. Just trying to understand, like the EIP explicitly states that self-destruct is discouraged, but there are definitely benefits, and they are trying to understand, is this intended as a transitional EIP, or it's going to be a permanent change for the EVM?
Right. So it is meant to be permanent. If there's a good reason in the future, because of the structure of Verkle tree, we could go the extra mile and produce something that would mimic self-destruct. But we still have this problem that, you know, all those hacks that were described in the first part of my presentation would become available again or possible again. So we would need a very good reason to do this. And yes, I'm aware of who, at least I think I know who asked this question. They are the very same people that we created this self-destruct in the same transaction in EIP-4. Yeah, don't tempt the devil, because you've been warned. We consider you've been warned. So we went a bit further to try to help you, but this is not a threat, right? I'm just saying you would have to be very, very convincing for us to help you if something breaks again, or if for whatever reason in the future we discover that you have been using self-destruct willfully with when we told you not to use it.
All right. This has been made clear to the community that people should not be using self-destruct. And in my memory, it was for the first time that we had a meta EIP went like documented ahead of this upgrade, where we are considering to have this feature removed, and like formally communicated it to the community that please do not use it. So yeah, as Guillaume already mentioned, that if you have some concerns, still some concern, please reach out to him or the team on Fellowship of Ethereum Magician. Hopefully you'll be helped over there. All right, you did mention about client implementation and testing. It looks like most of the clients have already implemented. I'm not sure if Ret is like a fully functional client as of now, but other than that, it looks like all other clients are there, like have already implemented. So we have heard that devnet 8 could be a feature complete devnet. That means it would include all the 5 plus 2, I guess 7 EIPs for the Dencon upgrade. So do we expect this to see with devnet 8?
I talked about this with Parry yesterday. I would have to confirm with him, but from the conversation, my understanding is that no, this will not be part of devnet 8, to be confirmed. But yeah, my understanding at the moment is that it will not be the case.
All right. So is it the only EIP which is not being considered, or is it just because we are going to have it 4844 specific again?
Yes, that's my understanding. It will be 4844 specific. Once again, assuming I properly understood what Parry told me, but yes, I think that's what it is.
No worries. I think we are going to have Paritosh here sometimes in a week or two to like explain about all about devnets and the progress that they have been making, how they are putting EIPs and what are the reasons why some of the EIPs were not considered. So we'll try to get an answer with him when he is here on our show. Yeah, I'll take your
I
answer for
will haunt
now.
him before that, but
Of course. All right. So I think that concludes all my question with respect to EIP and its specs. And I'll be now moving into the process part of it. I know this is not your first EIP. You already have documented a few proposals in the beginning. Maybe if you can tell us a little bit about your experience documenting an EIP or anything in specific that you would like us to change, improve, or you think is redundant, it should be completely out of the process.
yes. So indeed, I've documented some EIPs. I'm trying to be relevant here, but it's true that the whole EIP/ERC process is being overhauled. So I'm not following it day to day, so yeah, it's hard to be relevant. What I always find a bit difficult is that there's actually a lot of forums to follow. There's Ethereum Magician and there's ETH Research. I confess I have a tendency to follow ETH Research and always forget about Ethereum Magicians. So it would be nice if someone could remind me to get there, or at least, if EIP editors could actually point out to discussion and say, hey, this is happening, this needs your attention. That would greatly improve the experience. Apart from that, I can say, we will see what the new EIP process provides, but as far as I can say, it's just creating a GitHub pull request. It's about responding to comments, so that is fairly well streamlined. It's pretty simple, and I think it should be that simple.
Good to know that. And I'm happy to share here a piece of information for people who may not have followed it so closely. Like all discussion, we have tried to make sure that all of these discussions should be on Fellowship of Ethereum Magician. Ethereum research can be a source of information because most of the EIPs are stemmed from there. So we tend to add that as a source of information, and that too, the link be added in the Fellowship of Ethereum Magician. However, we have noticed that there are a few discussion going on the pull request itself, but our editors are trying to make sure to let user know that anything which is not related to specs should be discussed at FEM and not on the pull request, because pull request will get closed and people will lose the context. But FEM forum will be open forever and we can have the context if needed. With every change that we are pushing with a pull request, be added on FEM page so people can follow the links of every PR and have the full context of the proposal. What is it and why is it being added here?
Last time I presented, you told me something similar, and I've been a bad boy, and I didn't do it.
This is what we do. We try to share information, and I hope people will follow along. Just one more piece of information with respect to process here. I see the proposal is still in the draft status. We generally recommend people to move the proposal when they think that it is ready for community as well as EIP editors to have a proper review. Now that this proposal is being considered for DENCON upgrade and it is almost close to a devnet, my recommendation would be to create a small PR, just a status change, move it to review. And when the proposal is moved to the public testnet, like not Gorley, I don't know, Halsky will be around by that time. Whenever on any of the public testnet, then we can move it to the last call status. That's for the core EIP. So we'll really appreciate a pull request changing the status.
Will do.
That's all on the EIP status. And one last thing, because I know this proposal self-destruct has been under discussion for a very long time. Any success story or roadblocker that you would want to share with the community, like why it took so long and what were the precautions that you were trying to keep in mind before we finalize any proposal for the mainnet upgrade?
Yeah, I mean, the reason why is because it's a bit controversial. There's a lot of a lot of people. I mean, okay, we don't know how many people there are. We just analyze the blockchain and we figure out how many people there should be affected by this. But there's been some pushback from the community. It makes sense. There's also some proponents that really want to see self-destruct disappear because it simplifies. I mean, I think most core developers agree that self-destruct needs to go. So there's been some back and forth. There's been some informal conversations. The first time I heard this could be a problem is I was at DEF CON. I just made my presentation about Verkle trees, and someone came to me to discuss self-destruct and say, hey, this is going to break our use case. Yeah, we wanted to be cautious because if there's a lot of people out there, if using Create2 and self-destruct together was a pattern that was in widespread use, clearly we didn't want to break anything, or at least we wanted to make sure we're going to mitigate the bad effects. So there's been several proposals. They've been competing. We're trying to see which one is the most complex to implement, which one is the best. So yeah, it's normal core development process. In fact, I believe it's been quite fast compared, given the amount of competing ideas and emotion that has been put into this. I mean, if you want to see emotion, just go read the ETH research post. I'm sure the ETH Magician one is just as emotional. So all things considered, I think it's actually been pretty fast. But of course, yeah, hopefully this is the right choice. We'll figure out we'll figure it out at some point.
That is true. Like having a complete analysis of anything on decentralized ecosystem can be sometimes challenging, and we have many contributors with brilliant ideas. So there were so many proposals. Glad we have made it so far, and hopefully we'll have it on the mainnet very soon. Well, we are close to the end of today's episode. Do you have any message for the Ethereum community?
Keep staking, stake from home. That's that's all.
That is one of the best messages that we have received. I mean, like, it's very important to have diversity over there, and we would like to increase the percentage of solo stakers, as we have been talking with many of the CL devs in this show, that how they are here to help anyone interested in staking. So listen to all our developers, stake from home, become a solo staker today. Guillaume Ballet, we thank you for joining us on PEEPanEIP and talking about one of the most important and anticipated change with EIP-6780. From the announcement made with the Shapela upgrade, we are close to deploy this proposal for self-destruct only in the same transaction on the mainnet today. We look forward to seeing this proposal on testnet and finally on the mainnet with Tencon. On this note, thank you to all our YouTube viewers for watching and podcast subscriber for listening to this special episode. Should you have any question on this EIP or any other EIP, let us know in the comment below. Check out description for more information. We'll be back with another interesting talk. Until next time, keep watching, keep listening, and keep sharing your love with Ethereum cat herders. Thank you so much.